Imagine walking down the street in October 1930 in Indianapolis. An 8-story, 11,000-ton brick skyscraper is slowly rotating in the middle of the city. But the engineering marvel outside is nothing compared to the reality inside. 600 employees are sitting at their desks, completely undisturbed, while the massive foundation moves beneath them. Just listen to this busy switchboard. They are actively taking calls, handling paperwork, and serving customers, completely ignoring the fact that their entire office is physically turning on its axis. By the late 1920s, the Indiana Bell Telephone Company was growing so fast that they desperately needed a much larger headquarters. The problem was their existing 8-story brick office building, which sat right in the middle of the footprint where the new facility had to go. The standard approach was to simply tear the old structure down and build on the empty lot. But this was no ordinary office. This building was the literal nerve center of the Indianapolis telephone network. Every local switchboard, thousands of essential copper cables, and the city's primary communication lines routed directly through its walls. Demolishing the structure meant severing the city's vital telephone service for months. It would completely paralyze local businesses, cut off emergency responders, and leave residents entirely disconnected. Shutting down the network was simply out of the question. Trapped between the need to expand and the impossibility of closing, engineers pitched a proposal that sounded like pure fiction. Instead of destroying the building, they would physically move it out of the way. The plan was to slice the 11,000-ton skyscraper off its foundation, lift it into the air, slide it across the lot, and rotate it exactly 90 degrees to face a different street. And they promised to execute this massive relocation without dropping a single phone call. To move an 11,000-ton skyscraper, engineers first had to completely detach it from the earth. Workers descended into the basement and began tearing into the floorboards, digging through the dirt to expose the massive load-bearing columns holding the 8-story brick structure in place. They could not just slice through the concrete and steel all at once. Instead, the crew had to systematically replace the permanent foundation with a temporary mobile base. Crews painstakingly chipped away at the base of every single support column using hand tools. As they created narrow gaps in the foundation, they carefully slid heavy steel beams into the openings to act as the new floor supports. Directly beneath this makeshift steel framework, they positioned a small army of hand-operated hydraulic jacks. Transferring the immense weight of the building onto these jacks was incredibly perilous. A fraction of an inch difference between any of the lifting points would create deadly uneven stress across the rigid brick facade. That slight bend would be enough to twist the masonry, snap the active water pipes, and instantly sever the thousands of fragile copper phone lines connecting the city. At worst, a misaligned lift could trigger a catastrophic structural failure, collapsing the entire massive building while 600 telephone operators and employees were still inside answering calls. Precision was a matter of life and death. The engineering team positioned individual workers at every single hydraulic jack across the basement. They watched their supervisors carefully, waiting for the exact signal to move. On command, the men pushed the jack handles down in perfect coordinated unison. Just listen to the incredible strain of the initial lift. With that terrifying mechanical groan, the building was officially severed from its solid foundation. The permanent anchors were gone, leaving the massive brick structure hovering slightly above the dirt, balanced entirely on a temporary grid of steel beams and pressurized fluid. Now that the 11,000-ton structure was hovering on temporary steel beams, the most mind-bending phase of the project began. Moving a skyscraper was difficult enough. Keeping it fully functional while in motion was entirely unprecedented. Inside the brick walls, the Indiana Bell Telephone Exchange served as the communication hub for the entire city. The switchboard operators could not miss a single call, meaning the vital utilities pumping through the foundation could not stop for even 1 minute. Every rigid connection tying the building to the city grid had to stretch. Before the lift even started, plumbers and electricians systematically severed the brittle iron pipes and stiff copper wires beneath the floorboards. In their place, they spliced in specialized lengths of industrial-grade flexible hoses and elongated cables to carry water, gas, electricity and sewage. Most crucially, they had to protect the massive trunks containing thousands of individual telephone lines. Engineers added deliberate lengths of slack to these vital connections, creating a coiled umbilical system that would safely unspool and drag along the dirt as the structure slowly rotated. The building was essentially on a long leash, drawing all its essential power and water without a single second of interruption. But keeping the lights on and the phones ringing was only half the equation. 600 employees still had to safely commute into a migrating construction site every single morning. To solve this logistical nightmare, engineers constructed a heavily reinforced, movable passenger bridge connecting the fixed pavement of the street directly to the shifting front entrance of the exchange. This pivoting wooden and steel walkway featured a series of clever hinges that constantly adjusted to accommodate the changing angle and distance of the doorway as the building rolled away. When workers arrived for their shift, they simply walked up the gangway and stepped through the double doors into the main lobby. Once inside, they sat at their desks and went about their daily routines, completely insulated from the massive industrial ballet happening just a few inches beneath their feet. Beneath the floorboards where the operators sat, the actual mechanics of the move were remarkably ingenious. To execute the journey, contractors laid down an intricate level matrix of heavy steel rails over a specially prepared timber foundation. Instead of using traditional wheels, the building would glide on over 600 solid steel rollers. These acted just like giant rolling pins, squeezed tightly between the tracks on the ground and a massive grid of steel beams holding up the entire structure. But moving an 11,000-ton brick box requires an immense amount of localized controlled force. Rather than using explosive modern diesel power, the engineers relied on a single steam-powered stationary engine, which was connected to a highly complex network of pulleys, blocks, and thick steel cables. This mechanical advantage multiplied the pulling power of the small steam engine, creating enough tension to slowly drag the massive telephone exchange across the rollers. As the cables pulled taut, a highly coordinated crew monitored the progress from the muddy trenches below. They carefully watched hundreds of individual contact points simultaneously, adjusting hand-operated jacks to ensure the load remained perfectly level. If one single corner dipped even a fraction of an inch, the rigid brick facade could crack, or the entire structure could fail. Because the margin for error was so incredibly small, the operation proceeded at a glacial pace. The Indiana Bell building travelled roughly 15 inches per hour. This deliberate, creeping speed was the exact reason why the 600 employees working upstairs barely noticed the relocation. There were no sudden jerks, no swaying walls, and no spilled coffee. Workers reported that unless they looked out the window and saw the surrounding streets slowly shifting, they had absolutely no physical sensation of movement. The steam engine gently pulled, the steel rollers faithfully turned, and over the course of 4 weeks, the colossal structure smoothly rotated a full 90 degrees and slid completely intact to its new location. After 4 weeks of creeping along the steel rails, the Indiana Bell building finally reached its exact target, completing a perfect 90-degree rotation and travelling a total distance of 52 feet. But reaching the new coordinates was only the first half of the final challenge. The structure now had to be carefully transferred from the temporary roller matrix onto its permanent concrete foundation. This lowering process was just as critical and nerve-wracking as the horizontal move. Crews descended back into the muddy trenches using banks of heavy-duty hand jacks to bear the 11,000-ton load once again. Working in perfect unison to avoid cracking the masonry, they slowly removed the steel beams and timber supports layer by layer, lowering the massive brick box inch by inch. Throughout this delicate vertical descent, the engineering team faced their ultimate test in maintaining absolute utility alignment. The flexible cables and hoses that had supplied water, electricity, gas, and telephone connectivity during the rotation had to be securely transitioned into the brand new basement infrastructure. Every pipe and conduit had to align seamlessly with the new permanent fixtures while the building was actively moving downward. A single ruptured gas line or pinched electrical cable would have shut down operations and evacuated the site instantly. When the building finally came to rest on its new footings, the true scale of the achievement became undeniably clear. The contractors had not just relocated a staggering pile of dead weight and steel, they had successfully transplanted a living, breathing piece of vital urban infrastructure without interrupting its heartbeat for a single second. Upstairs, 600 operators had continued their shifts 24 hours a day, handling thousands of manual connections for the city of Indianapolis. Throughout the entire month-long physical relocation, despite traveling 52 feet across an active construction site, the telephone exchange did not drop a single call. This flawless move cleared the site, allowing Indiana Bell to construct their massive new headquarters. Just imagine being one of those 600 operators arriving every single morning to find your office sitting in a slightly different spot. Thank you for watching. Let me know in the comments what you think of this incredible achievement. If you want to uncover more astonishing engineering history, subscribe to the channel.